In problem 2.13, when an electron in a certain excited energy level, let's call it N, we don't know what that is. It's in a one-dimensional box, so we are still dealing with a 1D particle in a box problem. So the box length is given as 2 angstroms. And from this particular excited state, it makes a transition to the ground state, which is where N is equal to 1. So from N is equal to, maybe calling it N is not super intuitive. Maybe we can just call it N. Let N be the excited state. Makes a transition to N is equal to 1, which is the ground state. And during this transition, a photon of wavelength 8.79 nanometer is emitted. So we are asked to find the quantum number of the initial state, which is this, the excited state. Our initial state is actually the excited state because it's giving out energy. So we know the wavelength, so we should definitely know the energy that corresponds to this, and that would be 6.626 times 10 to the negative 34 times 3 to the power 8 joule second meter per second divided by 8.79 nanometers is 10 to the power negative 9 meters. So if we evaluate this term, it's going to be 2.2694 times 10 to the power 8 minus 34 plus 9, negative 17 joule. So this is the energy corresponding to the transition. However, we also know that the energy corresponding to the transition between states M and the ground state 1 is going to be m squared, 8 squared, or 8ml squared. Oh no, m is actually also not a great choice. So maybe I'm just gonna call it A to avoid any confusion. It's hard to pick alphabets. So this is going to be A squared minus 1. It's 8 squared or 8m squared. So A squared minus 1 is going to be the energy times 8m squared over 8 squared. We know the energy, which is 2.2614. We know the mass of the system, right? It's an electron, so the mass of the system, mass of the electron is going to be 9 times 10 to the power negative 31 kilogram times the length of the box is given as 2 angstroms. That is 2 into 10 to the negative 10 meters squared. So a joule can be cancelled out. And we showed previously that kg meter squared per second squared is the same as joule. So the second joule is also cancelled out. So this is basically unitless. Now let's go ahead and solve this or simplify this. 8 times 9 times 4. So I end up with 4.834 times 10 to the power They should all hopefully cancel out. So let's see. Yep, 10 to the power 0, so this is just 1. That implies a square is going to be 14.834 plus 1, which is like 15.834, which is approximately 16, right? So the value of a is going to be 4. So the transition happens from the energy level 4 to the ground state, which is the quantum number n equals 1.